Okay, look up. Okay, the key to today, listen. Tonight's homework actually is much easier than previous homework. They've done a good job of making it look harder. But as I often say, to be successful in the AP test, you've got to have a good understanding of calculus. You also have to have good test-taking habits. One habit you want to make sure you have is you don't get intimidated by what they give you. Just whatever they give you is what they give you. And then you just start working the problem. Don't worry about what it looks like. So here we go. Key thing to notice, again, you've got to go slow, don't go fast. This is the graph of F. Make a note, graph of F. Then they give you a formula for G. First thing now the formula for G is a little weird to me because it's got an integral, but integral's really just multiplying and adding, so that's no big deal. Give me a formula for G. They say find G of -1. Okay, nothing complicated. I just need to plug in x equal -1 into G. So I'm going to write on my paper G of -1 equals. This is where I'm not letting the problem intimidate me. I just work the problem. So I place a -1 in place of x. So in my opinion, the first thing they did to try and intimidate you is they give you a graph of F, and then they ask you a question about G.
So they just add up like no reason, just very well?
Uh-huh.
Oh, cool.
And they're also testing to see if you can understand that G and F can be related by this integral. So, 2 points for Chris. I would say the second thing they do to intimidate you is they give you a formula for G that has an integral. Instead of saying something like G of x equals x cubed plus x, which would not bother you because you've seen that for years, they give you something a little new, an integral. But again, don't let it bother you. Just keep going. So I plugged it in. The third thing they did to try and get you to just quit or get nervous is they make the limits come out backwards. 0 to -1 is reverse of what we're used to. I don't like to do integrals backwards, so I use a rule that says I can change the limits as long as I multiply the integral by -1, it's the same value. So just do that. Question?
Wait, are we multiplying it by -1 because the number that we're switching down to one is -1, or just in general?
Oh, really good question. So this -1 has nothing to do with this -1. Simply coincidence. The rule is if you switch the limits, just multiply by -1 and you haven't done anything. Like it's still exactly the same thing, just looks different.
Wait, why did we switch the limit?
Only because I don't like to have us integrating backwards.
Oh, okay.
We would be going from 0 to -1, which is legal, but I feel like it induces mistakes.
Okay.
So I prefer to just remember the rule, which says I can swap the limits. As long as I multiply by -1, everything's the
So
same.
they mean the exact same
I
thing.
mean the exact same thing. So the general rule is right here, Ashley, 2 points. Any integral is equal to the exact same integral with the limits reversed, as long as you multiply by -1. They're the same thing. So again, we really haven't done anything complicated in this problem. They've just done a good job of introducing things that are trying to make you uncomfortable, trying to, as Chris says, throw you off. But just work the problem. Is that pretty good to hear? Okay, next thing. We're supposed to integrate F, here's F, from x equal -1 to x equals 0. And we're integrating F, so there's F. dt means this axis, so we draw a line there. Okay? This right here, if I were trying to find this area, this is the integral I would have created to find that area. Because I would take the function on the top, this is what we just practiced in the blue packet. If I were trying to find the area here, I would take f, subtract 0, integrate from -1 to 0. Well, I'm not trying to find the area, I'm trying to find the integral. But they're one and the same thing. So over here, this area is just a triangle. So I can find the area without calculus. Picture a rectangle that's a little bit bigger. That triangle is simply half the rectangle. So the rectangle's area is 1 by 3. Half of that would be 3 over 2. So this is equal to 3 over 2 multiplied by the -1. So that's how I found the value of that integral, is I simply recognized that this integral would calculate this area. So I'm going to do it backwards. I'm going to calculate the area without calculus. Now I know the value of the integral. So that will happen all the time on the AP test. You'll have situations where they ask you to find an integral. You say, oh, wait a minute. I can find the integral by finding the area. And since I found the area, now I know the integral's value. We want to talk about that. Cool. I would add to your flashcards this one. So we've talked about how they're going to test you on 3 different ways to integrate, to find an integral. Riemann sum, calculator, and then we've been practicing the fundamental theorem and antiderivative method. A new method today. We now know that you can find the value of an integral simply by finding area with geometry. So the 4th method here is I use geometry. So I find the area. And by finding the area, I know the value of the integral. Question? Okay, so once again, hey, nothing complicated. Like, I have not done anything complicated. In fact, I don't have to write hardly anything. I just have to recognize a few rules. So. Okay, next thing. So I found g of -1. Make sure, this is an FRQ. Make sure you write g of -1 equals, otherwise the grader can't give you credit because he won't know what you're assigning to -3/2. It has to say g of -1 equals. Now we need to find g prime of -1. Okay? Again, not complicated. I know from many, many problems that if I have a formula for g and I want to find g prime of something, I need to take the derivative. So here's my formula for g. I need the derivative of that. So I write on my paper g prime of x is equal to d over dx, because this has to match this, and I'm taking the derivative of this formula. Question? So again, yeah, please go ahead.
Can you plug in the -1 there, or should we write that for the text like it's -1?
Hold on. Ticket question. Listen. Here's why it's a ticket question. If this were g, Marin's going to answer this for me, and you're trying to find g prime of -1, do you plug in the 1 first, or do you take the derivative first?
Take the derivative.
Right. So the rule doesn't change. It's the same rule. We just have a different formula. So we must apply a rule first, then plug in. It's a good question. So always apply the derivative rule first, then plug it in. Okay, look at your green sheet that I gave you long ago. The green derivative rule sheet. Like, it really helps if you look at the sheet as I talk. Yeah, Lauren saw it. Dang. So the rule I gave you long ago that had no use because you hadn't learned about integrals yet, now we can use it. So left side, right? Bottom there. We're going to use that rule. So you look at the green sheet, just listen to my words as I describe what I'm doing. The rule says the derivative of the integral of f, I believe this is f on the sheet, correct, is equal to f. the same function, right? But instead of using t, we plug in the upper limit, whatever that happens to be. So let's stop right there and see if anyone needs me to talk through that again. I haven't finished the rule, but that's the first part of the rule. Please.
What were we using?
So on your green sheet, bottom side left formula. The very bottom it says derivative of an integral. You see it, Chris?
Yeah.
So the derivative of an integral rule says you're taking the derivative of the integral of f. You simply plug in f. Like you don't have to do anything, just use f. Except that you plug in the upper limit in place of this variable. 2 points. Then you multiply by the derivative of that upper limit. So we have d over dx. It's crucial you get the dx right. It can't be dt. It has to be x because we're taking the derivative of g prime g of x. That's the first part of the rule. The second half of the rule is identical, hence memorization is easy. Just do the same thing with the lower limit. So it's an easy rule to memorize. Question? Awesome. The last part turns out pretty easy because this is 0, this is 1. So we've discovered that for this problem, g prime of x is equal to f. It's often that simple, just not always, so don't memorize that. Just use the rules. So you want me to do that again. So now we follow Marin's advice and say, oh, g prime of 1. So g prime of negative 1 is the same thing as f of negative 1. Here's my graph of f. F of negative 1 has a value of 0. Done. Collected 2 points now for really not doing hardly any work at all. Questions? Please.
Well, how did we find the 0?
Are you okay with this?
Well, yeah.
No worries, just making sure.
Yeah.
So it says, so I need to find g prime when x is negative 1. Good to there?
Okay.
Awesome. So the formula says that's the same as finding f of negative 1. Here's my graph of f. So I go to where x is negative 1, and the value on f when x is negative 1 is 0. Good question. 2 points. Now, solid. Keep going. So let's copy this over. Now we need to find g double prime of negative 1. So we just need to do another derivative. Can I erase this? Whoa. So I know that g prime of x is f of x. So I know that g double prime of x will be f prime of x. Oops, wrote that wrong, sorry. Questions? Plug it in. G double prime of negative 1. Same thing as f prime of negative 1. F prime means the slope of f when x is negative 1. So I come over to the graph right here. I'm looking for this slope. But that slope is the same as that slope. So that big long line rises 6, runs 2, done. I've collected 3 points so far on this problem. Question? You want me to say it again differently or the same? Okay, cool. Let's do another one. Finish. Give people a chance to write. So. Really, my opinion is, it really goes back to what Chris said. They just do things to throw you off, but you just rely on the rules, like the flashcards, the concepts. You don't worry about what it looks like, you just follow the rules. So. Okay. Let's do another one. Stop that.